Hello everyone, so let us continue with our exploration on Mininet. Till now we have understood how to use the Mininet in the terminal and run various commands in order to design various topologies and also look at the performance of the network. We have understood how to create topologies based on how many switches will be there and how many host machines will be there. Okay. Now we can always use Python programming in order to create topologies according to our plans. We have Mininet packages and we can use them in order to establish that. Okay, so here in this particular tutorial I will go through certain programs. We will go one by one and see how we can explore it. In a previous video we have used the Python code, however there was a certain thing to keep notice of. If you remember, this was the program that we run, and in this case what we did was we used the mn command in order to run this particular file. We tried to give the various parameters while running mn itself. Okay. However, now we will try to run a particular piece of code, or rather Python code, with the help of the Python software itself. So we are just going to call that particular file with Python, and then Python is going to go through the various codes and then execute them accordingly. Okay, so what I mean by that is let's try to dive into the particular examples and you will get to know what I'm talking about. The first program that we have is linear.py. Let us go inside the program. Here what we have done is, in the beginning we are using two packages. We have Mininet and then we have linear topo. So these are the two modules that we are going to use. We are going to use the various functions involved, the classes involved, and so on. In the beginning we are using this linear topo, okay, and then we are giving a particular argument. We are saying k is equal to 4, and then we are going to capture it in a variable called linear4. You can name it as you wish. Just named it linear4. Now this linear4 is going to be put in this particular value, or rather a variable called topo, and then we are going to call Mininet, and then we are going to put this particular class in the variable called net, and this net can be used to start Mininet as well as do various commands and then stop it as well. Okay, so first let us try to run this particular code and then we will move forward. So here we have Python. Okay, don't forget to use sudo because we are going to run Mininet commands with the help of Python code. We have Python 3, then the name of the file is one_linear.py. When we run it, what we see here is what happened when we run commands in the terminal directly. Here we are not going to do it directly, we are doing it with the help of Python code. Here you can see H1 is pinging to H2, 3 and 4. Similarly all the other hosts are pinging to all others. Okay, in a sequential manner. Fine, we have 12 packets and all of them were received properly, so we have 0 drops. Now let us go back to the program and try to know what is this k is equal to 4. What we mean by that is, of course, whatever we will have with this is going to be linear. I have already drawn that in this particular platform. Here you can see we have k is equal to 4 actually means that we are going to have 4 switches and each switch is going to have a host associated with it. Okay, so we have 1, 2, 3 and 4, and each of the switches is having a host connected to it. Alright, that's why we have k is equal to 4. If it is 1, then k is equal to 1. If it is 2, then k is equal to 2, and so on. Fine. That is quite simple and straightforward. I believe we have also tried out a command where we can directly go to the terminal, use mn, and then write the rest of the command in order to run it in the terminal itself. However, in this example we are not doing it. We are taking the help of Python. Okay, so let us move forward. Let us go to the next program. Next program is single.py. stop.py. Now what we have inside this code, we again have two modules called Mininet and single switch topo, and here we are using this class, and then we have a variable called k and a value 3 is provided to it, and then we are doing the same thing. We are creating a variable out of it, and then we are putting it in Mininet class, and then we are having a particular variable, and this variable can be used to trigger the network as well as ping and stop it as well. Now if you want to explore more about these classes, okay, you can easily do that. You can go to this particular API reference manual. You can search for various classes that you can use, okay, in order to make the objects and then use the objects for your convenience. Okay, so I will suggest you to go through the online documentation as well. However, for this particular session, whatever I'm going to teach, you can directly take this code and experiment with it. Now if we run this second program where we have the name as to_single.py, if we run it, we see a ping happening, so everything looks fine here. The only thing that's left is we have to learn what is this k doing, right, in this program. In this program we have k is equal to 3, and we have a single switch topo. That means there will be a single switch, of course, and then the number of hosts that will be connected to the switch is going to be 3. Now if we look at this particular diagram, we can easily get it. This is the second diagram. We have one switch with us, and we have 3 host machines connected to the switch. That means if we make the k value to be suppose 1, then one host will be connected. If you make it 2, then 2 hosts will be connected, and so on. Right, so you can customize it according to your wish, according to your plan, and then execute it and see the how this network is going to behave. You run commands and explore. Okay, now we move on to the third example, which is tree.py. What we have inside this, again we have two modules here which are imported. We have Mininet and tree topo. Again we are using tree topo, and here we have different variables here compared to the earlier one. In case of linear we had k, and in case of single we had k, but here we have two different arguments. We have to provide the value of depth and value of fan out. Okay, and then once you call it, you are going to put it in this variable, and then you can use it inside Mininet, and then you can use this variable net to trigger the particular network, and then do various commands and then stop. Fine, so let us try to run this code as well. We have tree_tree and run it, and yes, it is doing perfectly fine. Ping all is running, and the control gracefully stops, and then we come out of the CLI. Now if we go back to this code, we have two different values. We have depth equal to 2 and fan out equal to 2. Well, depth is nothing but the depth of the tree structure that is going to be created. So if you already know tree, you know what is the meaning of depth. It comes from also it is related to the concept of levels. So depth 1 means there will be one level of switch, depth 2 means there will be 2 levels of switch, and fan out means all of the devices in that particular tree structure are going to have 2 children. Now I have drawn that as well. If you look at this particular diagram, we see that we have 2 levels of switch. This is level 1, and this 2 is in level 2. So number of so the value of depth is going to be 2 because we have 2 levels here. Okay, again the fan out value is 2. That means every single node is going to have 2 children. So you can see this node has 2 children, and this node has 2 children, and this node also has 2 children, right? So both the concepts I believe is clear to you. What is the meaning of depth and what is the meaning of fan out in this particular code? Okay, so till now we have tried to understand different types of networks that we can make. Either you can go for linear, you can go for single switch, or you can go for tree structure. Okay, let us move on. Okay, so let us move forward and let's go to the next program. We have more.py, so let us see what we have inside this program. We have 2 modules. We have Mininet and CLI. Now why are we using this particular module? We are using it so that we can stop the CLI and not come out of it. So what is happening in the earlier cases is, as soon as the commands inside the Python code executes, okay, and once we stop the entire control, we just come out of the terminal, right? So here you can see we come out of the terminal. In this case too, we come out of the terminal. In the third case as well, we come out of the terminal. Now the problem is, sometimes you may wish to continue, typing new commands inside the console, inside the CLI, and in this case you are not able to do that. Suppose you want to analyze the various packet flow inside Wireshark, right? In this case you cannot do it, mainly because even before triggering this particular program, you cannot go inside Wireshark and tell Wireshark about the interface name, right? Because it has not been created, right? It has not been created, so you cannot do that. But if you are able to go inside the console and be there, then you can go to Wireshark and then mention the interface name, and then you can again ping or do iPerf or any kind of, or maybe client server communication, right? You can do any kind of activity, and then you can go to Wireshark and see how things happen. Okay, so that can be done if you go for this particular module called CLI. What we are trying to do here is we are trying to not only use CLI but also see how we can manually add the various host controllers, switch, etc., right, inside the Python code itself. Here we are making this variable out of Mininet, right? Then we are using this variable in order to call these functions called add controller, which is going to add a controller, then add a host with the name h0, then add a switch with the name as0, add a host with the name h1, because this was h0, this is h1, that is fine. Then we can create the links h0 to s0 and h1 to s0. So here it signifies that we are going to keep one single switch which will be connected to two different host machines. That's fine. Then we can go to this particular code and see how we can use IP addresses. So you can give your own IP addresses very conveniently with the help of set IP, and then also give the masks. Here we are giving the mask value of 24. So we have 24 and 24. Fine. Then we start. Then we want the CLI to pause there so that we can continue. Okay, and then finally stop. Let us see if this is possible. So here we are going to go to the terminal, and then we are going to go for the next program, okay, and run it. Now once you run it, as you can see, it does not come out of the control, right? It still remains in the Mininet console, so you can continue with this. Fine, this is very important, all right, because if you are given certain tasks to be done where you need to manually give commands, then this is going to be of great help. Now let us go to the Wireshark. Okay, let's open Wireshark and see if we can manage both the things together. Here we move to a different terminal and we try to run Wireshark. Okay, let us do it. Let us give the password as well. Wireshark is going to open. It's getting a little slow, but I'm sure it is going to work. Let's wait for some time. That is fine. We have Wireshark open. Let's see if it can read the interfaces that has been created. Here we have s0 eth1. Okay, so let us go inside the terminal and check for it. We come back to the Mininet console, and how do you check it? You can go for nodes to see the nodes, you can go for links to see the links, right? Or you can just dump the information by using dump. Here we can see that in case of links we see s0 eth1 and s0 eth2, and accordingly in the Wireshark we can see s0 eth1 and s0 eth2. You can pick up any of the interface to check that particular interface, and so let us try to see if it works. Let me clear the screen. So let me just check again what are the nodes we have, h0 and h1. Let us try to ping from h0 to h1. Okay, and we can give 3 packets. So we have -c, which is which indicates the flag to give the number of packets we want to send in ping, and we want to send it to h1. We have 3 pings done, and now let us go back to Wireshark, and yes, we can see the 3 messages going. So for each of the ping messages we have 2 messages, because one will be request, the other will be reply. So accordingly we see here we also have some ARPs happening. That is totally fine, because it has to be updated, right? The information has to be updated, and for that we need ARP. That is totally fine. It will happen time to time, no problem with that. But we want to concentrate on the ICMP packets involved here. Sometimes you will have a lot of other packets of different protocols moving around, okay, in the network. And in order to ignore that, what you can do is, suppose you want to go for ARP and ICMP only. In that case, you just type ARP and ICMP, and then you will only see the ARP and ICMP packets. In this case, I'm not sure why it's not appearing. Oh yes, it's not appearing because you cannot give ARP and ICMP. You have to give ARP or ICMP, and then press enter. And yes, you can see only the ICMP and the ARP packets. Either you can write down OR, or you can use the symbol for the OR operation. So let us try that as well. Yes, okay, it does the same effect. So that is cool, right? We can always check whatever activities we do inside the Mininet in Wireshark as well. It can be done. There is no problem at all. Fine. All right, so this is what I wanted to reflect upon in this particular code, how you can use CLI to pause the CLI to pause the Mininet console, and how you can shift back to some other sniffing tools like Wireshark or maybe Snort, and then run various commands in order to see the traffic flow, okay, to have an analysis of it. And you know, there is a limitless amount of work that you can do out of it. Okay, then we move forward to the next program. Let us see what we have in store. We have this program called performance.py. Here what we can do is, if you remember, we ran a program before where we mentioned about the bandwidth and the delay. Well, that can also be done with the help of the Python API that we have. In that case, we have to use these modules Mininet, CLI, then CPU limited host, in order to restrict the CPU utilization for a particular host. And then we have traffic control link in order to have a particular parameter for links. All right, so here in case of simply calling Mininet, we are also going to put these values here, and then we are going to take this variable to create a controller, then switch, then host, and so on. Here you can see that we are trying to use 50% of the CPU. Okay, we are using 50% of CPU for H1. We are using 50% of CPU for H2. Okay, so that means if it was getting certain amount of CPU utilization, okay, if it was getting certain ratio of CPU, then it is going to restrict it to half of that. Okay, all right, so let's move on. We have CPU is equal to 0.5 for H1, and CPU is equal to 0.5 for H2 as well. You can remove these values and still is going to work. Okay, you're not bound to give these values. That's totally fine. It's still going to work. However, if you want to restrict it, you can always use this option. Then we move to the most important part. We have a bandwidth of 10, and that is 10 megabits per second, and then we have delay of 5 milliseconds, and we want to do it for the link S0 and H0. Okay, this is not a default value for all the links. It is only going to be applied upon the link where you give these values. That means S0 and H1 and S0 and H2 are still going to go for the default values, and they are not going to pick up these particular values. Okay, then we start the network, and then we pause the CLI console so that we can do further work. Let us dive into the terminal and see if it runs. Here we are going to gracefully exit from the Mininet console so that we can come back again. Wireshark says that it cannot see the interface anymore. That's totally fine and practical, so we are going to close the Wireshark. It was still listening to the earlier interface, but we have stopped it, so it's not going to see it anymore. So we will say bye to Wireshark. So we stop it. Now we are going to go for the next program. The next program is 5_performance. We are going to run it. Nice. Then we are going to look at the various information by giving these values, and we can also go for dump to have an overview. Okay, that's totally nice. And then we have these links H0, we have these nodes H0, H1 and H2, and we have these particular links with us. Now if you remember, we tried to restrict the link of S0 and H0. Okay, we gave only 10 megabits per second of bandwidth and 10 milliseconds, I believe. So let us see if it gets reflected. You try on your own with respect to pinging, okay, so that you see the delay in the network. However, I'm going to show you about the bandwidth. So for bandwidth, you simply have to go for let's just ping it once so that we know that everything is fine and machines can listen to each other. We are going to go for single packet, no problem with that. And here we had the ping, okay, we had 23.5 milliseconds of round trip time. That is totally fine. And then we go for, let me clear the screen first, and then let me go for iperf command in order to get some performances. So H0 and H1, remember we restricted the link related to H0, so let us see if we get lower values of bandwidth in this case. And yes, as we can see, we have these values that are close to the value that we provided. We provided 10, it is 9.26 and 11.1. That's totally nice. However, if we try to see the performance of links which does not have inclusion of H0, okay, let us see what kind of bandwidth is shown in that case. So if we don't take H0, suppose we take H1 and H2, now we don't have that link with smaller bandwidth values. Let us see what happens. Yes, so you can see the values here. These are the default values. This is actually the bandwidth that this network is getting, okay, by default. And here, since H0 is not associated with it, that link is not touched or used, so we get the entire bandwidth. Okay, even in case of H2, and it will be same, right? If you do H2 and H1, it will be same. So you can just try it on your own, but it's same, right? We are not involving H0. Even if we take suppose iperf, okay, if we take iperf H0 and H2, which was not taken earlier, so let us see for that as well. And in this case, H0 is involved, so you know the bandwidth is going to get affected. So here you can see we have again 10 as a value, and here also almost 10 as a value. So we always get nearby values because we get the real-time values, and yes, it is going to work. So that's totally fine. I believe you have understood how to use the CLI and how to actually test the various parameters that we have put in the Python code. All right, then we move to the last program, which is helpful. So let us see if it is helpful or not. Here I simply wanted to show, it's almost same as the previous one. Here I just wanted to show that you can also do normal pinging and iperfs inside the code itself. Okay, you can try it on your own. You can just uncomment these lines and see what output you get. So apart from showing you how to use controllers, switches and host, okay, how to add them and how to give various CPU utilization ratios and then bandwidth values and delay values, right? Apart from them, I'm just trying to show you that you can also ping, okay, normal ping, because earlier we did ping all, but you can also do ping for two specific machines, and you can also do iperf for two specific machines and get the output back. Okay, if you want, okay, let me just run it. First we will gracefully get out of the Mininet console, and then we are going to run the last program. So this is the last program we have, and we are going to run it. And then as we called iperf, it is going to run, and you can see we have the values here, H1, H2, because see, H0 is not involved here, and H0 has the bandwidth restricted, and since we are calling H1 and H2, this link is not going to be used, and so we have the default values of bandwidth that is utilized or used. Okay, but you can just try out different values. You can go for H0 and H2, or maybe H2 and H0 and so on, and try out the various output you get. Also at the same time, you can just open Wireshark and see what kind of packets are going and coming, right? What are the packets that are involved in the traffics that you have triggered. All right, I suppose this is quite simple and easy and fun to do. So I wish that you will I hope that you will practice these examples as much as possible and try to get grips of the basics of Mininet. So with that, I would like to wind up for today. Thank you so much.